Hey guys, welcome to this video from Law of Learning. This section we're going to be talking about is under physics, which is the motion unit. So before we actually, go further in depth about, this about physics in terms of motion, like in a more detailed perspective, it is, best to let's define some terms which we will be constantly referring to while solving different problems involving motion. Now these terms you will most likely, not most likely, but 100% you will be hit with these terms throughout your course of study. So the terms we'll be talking about are scalar, vector, distance, displacement, and velocity and acceleration. Now off the bat, you guys, some of you who are viewing, off the bat will know some of the meanings of these definitions just because of the nature of the word. However, there's some confusion in some of these words as well, such as distance and displacement, velocity and acceleration. So hopefully we'll learn more about the distinction between these words and how they apply into physics. Okay, so we're going to start off with scalar and vector. So before we actually go deep into explanation of what these two terms mean, let's start off with a definition. Now, as you see, vector is defined as quantities that have magnitude and direction, while scalars are defined as something that as quantities that have only magnitude. Now let's illustrate what these definitions are saying with an example. Let us say that there is a car that is traveling. Please excuse me for the lack of artistability, and that's even a word. This car is traveling, let's say, 50 kilometers per hour east. Right, 50 kilometers per hour east. Now, I want you guys to look at what I've written as 50 kilometers east. Now, this can be divided into two sections. The first section, let me just change color just to show you, is the blue part color is the scalar part of this statement. The scalar part would be this 50, because this is telling you the magnitude of how fast this car is traveling. The magnitude of how fast the car is traveling. This 50 can be 100, 150, whatever. But it's independent. This magnitude is independent of the direction it's traveling in. So you can have a 50 kilometer per hour car traveling east, a 100 kilometer per hour car traveling east. The 50, or the number, is the magnitude of what is traveling. Now, the vector part, what makes this statement a vector, is that it is traveling east. This is its direction. This is telling us that, okay, we have a certain quantity that has a magnitude, but it doesn't have a direction. Is it moving anywhere? This is what a vector quantity is. So in essence, this whole thing is a vector quantity. A vector quantity. Because, again, it has a magnitude and it has a direction. Right? So this is what it's trying to say. Now let's look at some other examples of only scalar quantities. So scalar quantities, like I said, only have magnitude. Only have magnitude. So some examples of what scalar quantities are is mass. We have this block that weighs, let's say, 100 grams. This is a scalar quantity. We have time. 10 seconds. 20 seconds. This is scalar quantities. Now we even have, let's say, age. Right? We have Tim. Hi, Tim. He is 5 years old. This is, again, scalar quantities because they only have magnitudes. These are all magnitudes, which makes a scalar quantity. So these are all scalar quantities. Because, again, I know I'm saying this a lot, but it's just to reiterate the message that they only have magnitude.